what we're going to work on in this unit is the real number system and working with particular types of numbers. So what we want to first do today is go through the real number system. Now, as in many things in life, food, animals, minerals, rocks, whatever you want to term it, people like to put them in categories, because when something's put into a category, that means it has certain attributes. And we do the same thing in math. And this is really a building process. So what we're going to do is identify the different categories in the real number system. We're going to give you a description and a way to remember it, and you'll see how this builds. So natural or counting numbers are the numbers starting at 1, 2, 3. And what we're talking about is we're counting objects, right? So if we're counting actual objects, it's a whole person, a whole of something, all right? So that's what we're talking about when we talk about natural or counting numbers. Whole numbers just tack on a 0. So it's the natural adding in 0. Okay? Integers are the introduction of negatives. So it's the whole numbers and their negatives, and it's like a number line. Okay? Next one, rational numbers. Now this is where it gets to be a little bit tricky. All right? If you see the word rational, embedded in the word rational is the word ratio. And as we've done earlier in this course, ratio refers to a comparison of two numbers using division. So a rational number is the quotient of two integers. The denominator cannot be 0. Okay? So what we're talking about is a terminating decimal. And we're going to do more with these rational numbers and irrational numbers later on in this unit. A repeating decimal or where we can remove the radical. Okay? Irrational numbers are those that cannot be written as the quotient of two integers. Basically, we put them into a couple of categories. Pi, non-perfect squares, like the square root of 2, and non-repeating, non-terminating. Decimals. So for example, the decimal 1, 2, 3, 4, dot, 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 that doesn't terminate, it doesn't repeat. Okay? And then real numbers is the set of all rational and irrational numbers. And it's everything we use in this course. When you get to Algebra 2, you will come across what are called imaginary numbers. And those are numbers that are used in science for certain science formulas. All right, so let's just go through these examples. The number 1, 4, 1, 1, 4, etc. That is irrational. It's following a pattern. It doesn't terminate. That's what the 3 dots mean. And it doesn't repeat. Okay? Which number below is rational? Or is irrational, I'm sorry. Radical 20. Square root of 121 is 11. The square root of 4 over 9 is 2 over 3. Why is the number you chose an irrational number? It's not a perfect square. Okay? Which is an irrational number? Square root of 3. What tricks people sometimes is they say 3.14 and they think, oh, that's pi. No, that's, first thing is, it's the number 3.14, and pi is only approximately 3.14. As you're well aware, pi is a number that goes on for infinity. Excuse me. All right? Which is an irrational number. Excuse me. 1, 2, 3, 4, dot, dot, dot. Similar to above. Which of these 3 is rational? The square root of 196, because that equals 14. And the value of the square root of x squared minus 9 is a real and rational number when it is equal to 4. Real and irrational, I'm sorry, because that means it's the square root of 7. Okay? If you put the other numbers in, when you put 25 in, you get the square root of 16, which is 4. That's rational. When you put negative 3 in, negative 3 squared is 9. You get the square root of 0, which is 0. That's rational. When you put 0 in, you get the square root of negative 9. That is definitely not a rational number. Okay, so what we covered today was the categorization of numbers in our real number system.